We continue learning workbook page 216 with this problem. Solve 2,000 equals 18,000 e to the negative 0.4t. Okay, this is an exponential equation of type 2. So, here's my first question to you, and it's an important question. I want you to respond out loud, even though I can't hear you. What's the base on the right-hand side? Answer out loud now. If you said E, you're correct. The base is not 18,000e. And the reason I know that is because there are no parentheses. If I wanted the base to be 18,000e, then both the 18,000 and the e would have to have parentheses around them. Absent those parentheses, the base is simply e. Okay, so now that we know that our base is e, we look at this and we see that this is of the form number times base raised to exponent equals number. And that does not match the form of what we have. There is no number multiplying by the base raised to exponent in this form. So, in order for us to solve this problem, the first thing we have to do is get rid of the 18, and we do that with division. Okay, so we divide 18,000 on both sides. So divide by 18,000 here and here. And reduce the fraction. 2,000 divided by 18,000 is the fraction 1/9. The 18,000s cancel, and over here I'm left with e to the negative 0.4t. All right, so you could write 1/9 as 3 to the negative 2 power, but there's no way you're going to make the 3 and the e have a common value. This is definitely a type 2 problem. The two numbers here are not powers of the same value. So we need to use a logarithm to solve this problem. And the advice that I gave you earlier was use the base that matches the base of the problem that you're working with. Well, the base of the problem we're working with is e. So we need to use a logarithm whose base is e. What kind of logarithm has a base e? A natural logarithm. So we're going to take the log base e of both sides. Natural log of 1/9 equals the natural log of e to the negative 0.4t. Or if you prefer, log base e of 1/9 equals log base e of e to the negative 0.4t. Now, this second form is particularly convenient for us, as we'll see in a moment. We're going to move this exponent to the front of the log using our power property. So then we will have log base e of 1/9 equals negative 0.4t times log base e of e. And I'd like you to notice that at this moment, we have a logarithm whose base and whose argument are both numbers. Whenever it happens that the base and the argument are both numbers, you should stop and ask yourself this question. Can I rewrite that as an integer? Let's find out. Log is EGOB. Log is a missing exponent. So what is the exponent that goes on base e to make e? The answer is 1. E to the first power equals 1. 1 is the missing exponent. So the value of the logarithm is 1. So this entire red box here is just the number 1. All right, so we're going to rewrite our next line of algebra so that it ends with negative 0.4t times 1. And on the left side, instead of continuing to write log base e, log base e, log base e, I'm finally going to put this back to natural log. So natural log of 1/9. All right, we know that anything times 1 is itself. So I can just erase this, e. And then I can divide by negative 0.4 on both sides. Those coefficients cancel, and that tells me what t equals. So my final answer for this problem is t is exactly equal to the natural log of 1/9 divided by negative 0.4. Now, If you're not happy with the fact that this includes a fraction and a decimal, this answer can be rewritten, and the steps for how to do that are shown in your learning workbook. However, they are not necessary to get a final correct answer. If you put this in Alex, you'll receive full credit for the answer.